In this video, we'll cover something called converting octal to binary. It's very simple, but it's usually you need it when you study electrical engineering or electronics engineering also. Also, sometimes they use it in computer. I'm not sure how and why they use it in computer science, but let's cover these topics and break it down. Okay. So this is in the octal system. So this is the number between the parentheses. It is 65, and we will discover it will equal this number in binary. And you see between the parentheses, the blue line, it is, or the blue numbers, it is in the binary translation from this number. So when you have octal number, we will break it in. Let's put every bit as its own. So 1 here and the other one is here. So 6 will go here, 5 will go here, and every octal number will break to 3. In the binary, we know, like, we start with 1, then we go to 2, then we go to 4, and then we go to 8. And why we don't go to 8, we stop with 4 here, because it's octal. It doesn't go to that number or to that level of a number. So 6 will equal 4 to 6 will equal this number. You see it in the blue. Why? Because 6 does it have 4? Yes, we'll add 1 here, and the rest of that will be 2 from the 6. So 6 minus 4, because we took already 1 here. So we will then we will have after that 2. Do we have 2? Yes, we will add 1 here, and then we will say 2 minus 2, so it will be 0. Do we have a 1? No, in 0 we don't have 1, so we'll put 0 here. And if you add like 4 plus 2, it will equal 6. This is another way to make sure that your answer is right. So we go to this number 5, and then we put 4 to 1. If you don't need to put 4 to 1, the next example will not add this one, but just to make it easier and to break it down. So does 5 has 4? Yes, we'll add 1 here. So then we will make this one 5 minus 4, it will be 1. So does 1 has 2? No, 0. So we will go to next bit. Does 1 has 1? Yes. And even if you take this number, we have 1 here and 1 here, so we'll add 1, which is equal to 4, and 1 equal to 1. We will add 1 here and 4 here, and it will equal to 5. Again, we'll cover another example to make it easy. So we have this number in the black, this octal number. You see between the parentheses, then we put outside the number 8. So we have 3, 4, 2, or 342. It is an octal. So we will break every one of them to 3 bits. So this one got 3 bits. Does 2 got 4? No. So we are not putting this one in this exam, but we are assuming it is somewhere here. Okay. Does 2 has 4? No. So we'll put 0. Does 2 has 2? Yes, we'll add 1, and then we will remove 2 from 2, or we can make it 2 minus 2. So it will be 0. Does 0 got 1? No, we'll put 0. So this is the translation of the octal number, which is this one. Okay. Now we go to the next one. Does it 4 has 4? Yes, we'll add 1. Then we said 4 minus 4, it will be 0. Does 0 has 2? 0, no. Does 0 has 1? No, we'll put zeros. So this is what we got from the first 2. Then we go to third one. So we have 1, or what equal here. You can assuming the black is somewhere here up. So 1, 2, 4. So does 3 has 4? No, we'll put 0. Does 3 has 2? We'll say yes, so we'll put 1, and then we said 3 minus 2, it will be 1. So we have still have 1 after that. So does 1 has 1? yes, we'll add 1 here. So this is in the binary equal to this one in the octal. And you add, if you add 1 plus 2 will equal 3. Like here. And you add 4 to 2, it will equal 6. So the translation of this one from octal, or converting this one from octal to binary, this is the answer. You can add all this together and you will make it, or it is, you can see it is equal to this number. And some people, they keep some space, which is not accurate, but many of the teacher will say, okay, you know, but try to, if you want to make it perfect, try to not to keep distance between, you see, between those 3 numbers and those 3 numbers here in the final answer, I mean. Thank you for watching. If there is anything, you can add it to the comment, and see you again.